So, does that work? Okay. So, I just wanted to say this because there's been some talk about funding, and I would say that I bridge the cognitive education and natural sciences domains, and the funding pool for climate change education has skyrocketed in the last few years. There's 3 calls that just came out, and I think the things that Sandy and I have worked on are some grant proposals, and really thinking about the ways in which we're doing very similar work, but talking and publishing in different communities is, I think there's a lot of really interesting opportunity. So what I'm going to talk about today is some visualization research that we're doing in my lab. And the fundamental question and the way it relates to this is, what are the messages that the public is getting? And how are they interpreting those messages? And those messages are coming from scientists. Scientists build visualizations generally, and text that goes along with it, to communicate with each other. And then what typically happens is that those visualizations are simply modified a little bit and sent out to the public and the news media, et cetera. And so the question is, are those effective ways to communicate? And how does that impact the way in which the public then thinks about issues like climate change? And this is work that was done in collaboration with Scott Clark, who's in the lab but off to a faculty job in Wisconsin. Yay. And then also the art director for the Earth Observatory at NASA. So NASA houses, I just learned this for a grant proposal, NASA houses the largest concentration of climate scientists in the world. The Earth Observatory disseminates about half of the climate information that comes out of NASA. So this is a place where climate information is getting out, and then people can go and just grab these images off the Earth Observatory. And in fact, that's what people do. A journalist colleague tells me that that's what they do. They go on to the USGS or the NASA site, and they just grab these visualizations. So what I wanted to talk about is the concept, is that in focus? Ish? Yeah, okay. I need glasses. The concept of visual literacy. So really thinking, learning, communicating with images. And some of the work that we're doing is actually thinking about the relationship between visual cognition, social cognition, and verbal cognition, and what are the intersections between those domains. There's a really long history in design fields and communication and other fields about best practices for, say, generating visualizations. And the thing is that, do scientists have a best practice when they generate these images, or is it really something that's being done by feel? And I just wanted to show you, this is something that Robert Simmons sent me. These are 3 identical data sets. It's the same data, and it's actually, it's sea surface level data, represented actually by 3 different groups at NASA, right? And they're all represented in different ways. And in fact, you can actually tell it's the same data set because this feature, the sea level feature, is all there. But I view these very differently. When I just look at them anecdotally, I think, wow, these are different data sets, or they're showing me something different. They're actually showing the exact same thing. And the question is one of these the best way to portray information to children, to the general public, to people who have some knowledge about climate change, to budding climate scientists, et cetera? Maybe we need multiple kinds of visualizations. So what I'm going to do is talk just a tiny bit about a little bit of a background, and then just show you a study that we just conducted in our lab. That's a baseline study that will then allow us to really target climate imagery. So one of the things that I think is really important to remember or to recognize is that the colors that we use and the way in which we structure our visualizations are going to impact the way in which people perceive these visualizations. So people are going to look in certain places on an image and not in other places, just as a function of our colors and just as a function of our structures. So I want to show you some data that's come out of the lab that Scott Clark's worked on. This is a classic image that relates to plate tectonics. And some of the interesting findings are, for example, that when novices look at this image, so people who have no training or very little experience in entry-level college course in geology, when they look at this image, the novices are all looking in the sky. The experts never look at the sky. Experts know when they're looking at this image that for the general plate tectonic processes, the atmosphere doesn't matter. So they're not looking there, but novices are. So if we're scientists creating this imagery for the general public, we have to recognize that they're going to be looking in different places. And similarly, color has an impact. So you may not know this, and that's fine, but the Earth is completely solid, except for the outer core. So this part of the Earth is solid. It's just solid. However, when people look at this, it's orange, it's yellow, they think of a liquid. That color primes a cultural norm, which is that these oranges and these yellows and these reds, at least for the earth, things that we learn, let's say, in elementary school, that relates to a liquid. And so the colors that we choose are going to impact the perception, the understanding that people gain out of this imagery. So we had an opportunity for another study that I have. We rented an eye tracker, and it was a mobile system that we took outside, and we were looking at how novices and experts look at the outside world. And you've probably seen some of this work done in scene perception, and we're housed in more of the geological sciences, so we're applying that work to a different domain. So I had this opportunity, and so Scott and I pooled some money from some different grants, and we rented it for an extra week, and we had it in our lab. It was not the ideal system, but what was cool about it was that it introduced some problems with the data analysis that has given us some innovative solutions, which I think can be applied to other data sets. So what we did, we had two questions. If we have just some simple imagery related to temperature, will the color of the temperature map change the way in which people are just looking at that map, and then their discourse about that map, and their understanding of the information that's being portrayed? And then does experience level, does expertise in a domain or lack of expertise affect the way that you look at this imagery? And I think we would all say, well, of course, both of those things are going to affect it, but I always like to test our assumptions and have some concrete data that says yes or no. So we were able to grab, and in a week we ran all day this study, and we had 31 people that ranged across the novice expert continuum. So this was our design. We did a color blindness test, so we had before the day of the experiment for each individual, we actually had people come in at the beginning of the week. We ran a color blindness test, which was fascinating because there was actually one subject who failed the test, and we said, you may want to go see someone. We couldn't say anything else. This was an adult, right? But it was fascinating to me because I guess you can not be able to see color and not know it. It's just amazing to me. We had an experience questionnaire, the geoscience experience questionnaire, which is something that we use. They were getting at, what is your experience level in geosciences? We realized later we also needed to know geographic experience. So we asked those questions in an interview. And then we had lots of demographic data, and this is the experimental design. Basically, we had 3 temperature maps, which were made by Robert Simon at NASA. These were average monthly temperature in March of '09, I think. And these are exactly the same data sets, but 3 different color palettes. And Robert's the art director of the Earth Observatory, so for him, he's very frustrated. This is the palette scientists want to use. And he's trained in some cognition and graphic design, and so he finds this frustrating because he knows that there are issues, he feels that there are issues with this, there may or may not be. And he would like to get some data that would allow him to tell scientists, this is great, or why don't we try a different color palette for portraying, say, temperature or other data. So this happens to be temperature data, but these are actually the same kinds of palettes that are used to portray everything, salinity, population, etc. So I wanted to show you some of the data. So what you're going to look at now is some of the raw data. So the eye tracking system has a camera that views the scene, and it also views the position of the pupil. So what you're going to see is a crosshair that tells you where the pupil is, okay? And what you're going to see is a subject actually looking at a scale. And the video samples 29 times per second. So you're just seeing less than about a second of this. What's nice about this data is that as they're doing this, they may be answering some questions, and it's really incredible that you can see them look somewhere and then talk about it. So there's this real nice match between these 2 data sets. Because it was a mobile system, we actually had to have a cadre of undergrads digitize these data for us. There's a lot of data. So what we did was we just looked at, what I'm going to show you is the first 10 seconds of viewing behavior. Oh, and I forgot to say it was a randomized design. We had these 3 maps, and each subject saw a different map first. Some saw the gray map first, some saw the purple map first, and some saw the rainbow map first. We're interested in training effects, but we're also interested in, you see this map, you look at it, where do you look? If you don't look at it, you're not perceiving it. So then you end up with things like this. So for example, this is an individual's eye track path. And the eye has unconscious movements that just flickers, and the eye has what people sort of assume are conscious fixating behaviors where you're actually gazing purposefully. So this is an unfiltered data set, and there's a digitization of 29 points per second, so we had our students digitize how many months, Scott? It was a number of months of 290 points for each map. And then you end up with something like this, where this is a cohort map. And so this is the 9 people, you'll see this in a minute, but this is the 9 people who viewed this map first, and where are they looking, okay? There may be individual difference, but we're actually, for us, these numbers are actually not small. These are good numbers of subjects. So these could be individual difference related, but you're starting to get into the realm of if there are true differences between view behavior, individual difference is going to be, the probability that that's responsible for differences is starting to become very low. So what are the findings? Oh, right, we couple this with interview data. So for example, we had lots of interview data, and we had a subject who said that they felt that this map was easier to view in Antarctica than the other map. Okay, so there's some preference behavior. Women, this is anecdotal, but generally the women tended to say, ooh, pretty, when they saw the pink map. We never had, I don't think we had anybody say that. One guy? Oh, one guy said that too. And everybody liked this map, and the gray one was boring, which to us as scientists, we love the gray map. We thought it was great. But there's an affective component. I would say now, don't use gray, because it's really boring to the non-scientist. And some scientists do. And then we had other interview data. So for example, we asked questions like, what is the temperature difference between here and here? Just ask that. Looked at their view behavior. We found that a lot of novices didn't look at the scale. They just sort of guessed. Or they would say something without looking at the scale. And especially on the rainbow map, because they know what color means on the rainbow map, or they believe they do. Whereas this is an expert saying, well, I looked here and then I looked here. And in fact, when you go back to that to the question where you said, what's the temperature difference, their eye purposely flickers or gazes between the map and the scale. Okay, so to answer the questions, does color palette impact behavior and understanding? The hypothesis would be that, yes, there's going to be a difference between color. And again, we're all going to say, well, this isn't easy. This is easy. I know the answer already. But again, I like to have the data. So I'm just showing you 2 of the maps. These are, again, the first viewed maps. There were 9 people who viewed the rainbow map first, and 9 people who viewed the purple map first, 2 different groups of 9. They actually ranged across the expertise levels, so there were novices through experts, and we actually see fixation differences. So if you look at the color palette, what you see is that people are really fixating on the reds and the blues. And I'll tell you about this in a minute, but I have a colleague, Kurt Goldsberry, in geography, who's working with some of the geographic information systems people to analyze these data, because it's temporal spatial data. And we're actually analyzing statistically the differences between gaze behavior in the greens on this map and the same zones on the other maps. Green is actually something, there's lots of work on this. It tends to be, for humans, a background, and we see things on top of it. We don't see it as something we need to look at, which is really interesting. So if you look, I see some interesting differences. To us, one of the coolest differences is the scales. So if you look here, no one is looking here on that, at those greens. There's some gaze behavior on the reds, but if you look on this map, in that same zone, there's much more gaze behavior, and there's much more gaze behavior at the ends. So the question is, we want people to look at those scales. How can we encourage that? How can we make these images more salient and relevant? And then I wanted to just show some of the interview, the think aloud data, or the speak aloud data. And there's a lot of research that shows this, but this just backs it up, that reds are hot and blues are cold. And what's interesting to me is I was at a conference on climate change education, and there was a map that represented salinity data. And it took us minutes to figure out that that's what it was representing, and that in fact the continents were the grays and the oceans were the colors, because we're used to that being a temperature palette, nothing else. So the question is, for different kinds of data, what palette should you use? So that's one kind of data. And then, does expertise impact view and understanding? And we would argue yes. This analysis is ongoing because we need that GIS work to really get at this. But I can show you some of our initial findings, and one of them is that experts spend more time on the scale than the novices do, especially during that first view. I think there's a training effect, so subsequent views, people are looking at the scale, so maybe we should do just purposely train. Have a very simple map, and then show them the climate map. And then, the expert gaze behavior is much more deliberate than the novices. I call it sort of place scale behavior. So the experts, and this is an expert-like, it's not a data set, it's sort of an amalgamation, and so is this one. So the experts do things like they gaze at a point and then go to the scale, gaze at a point, go to the scale, gaze at a point, go back to the scale, gaze at a point, go back to the scale. The novices don't do that. So even if the novices are spending, let's say, the same amount of time on the scale, it's less purposeful and perhaps less meaningful. So I would wonder if the novice even got in that first 10 seconds of gaze much out of this image. If you think about people reading a news article, 10 to 30 seconds is what people spend on the images. So what are the implications? Okay, yeah, experts and novices view these things differently, and color plays a role. But this is the base study that's needed to then really get at these climate data. So we have this GIS analysis that's going on. And then the next step is to look at these classic climate imagery and then collaborate with the sociologists to get at these other variables, the demographic variables, the political view variables, that really, the decision-making variables that really seem to influence view behavior and understanding. Collaborate with some of the linguists, try to get at how the text interacts with these. And then these are images that you guys are, I'm sure, very familiar with. These are from a United Nations environmental program site, which is one of the biggest places to get this kind of data. And I look at these, and there's all sorts of things that I'm trained as a geologist. I don't understand what they're showing me. I don't know how, say, someone in the general public is going to understand what this means. The other thing I found really interesting is that the color palettes, there's no relationship between these are model data of sea level rise and the same palettes that are being used for stress on freshwater and similar palettes that are used for, say, temperature and CO2. So there's all sorts of things about these that I think we could study and then very carefully figure out perhaps a simpler way, a clearer way to portray this information. And I should say that with that plate tectonics map, Scott has completed this study and in fact has come up with a graphic artist, a better image that geologists will look at and say, oh, yeah, that is a better image. That is a better way. So if you can get multiple stakeholders to say that this is clearer, that's the ideal. That's all. Thanks.
Computerized gaze analysis of classic images like the Julie.
So this is what's fascinating. It's actually a little bit hard to figure out what's been done because there's people in geography doing this work, there's people in communications, in sociology, in the graphic sciences doing this kind of research. As far as I can tell, cognitive science, what I discovered, and the reason we actually ended up doing this experiment, is that cognitive scientists often want to remove the context from their research. They really want to get at those fundamental processes. So some of the work that's happening right now, they make up a data set, as opposed to using a temperature data set or using a Keeley curve or something like that. So as far as I can tell, and even the geographers make up data sets. So we have this wonderful eye tracking researcher here on campus, and they have made up some maps about ice cream usage, something like that. So as far as I can tell, there are people looking at these things, but they're not saying, okay, let's do it on a climate imagery. One of the problems is going to be, if we do come up with better images, how do you convince the scientists to use them? And that's where people like Robert Simon, who is the art director of the Earth Observatory, comes in. He ultimately has control over what gets disseminated, at least through the Earth Observatory.
And the second, you mentioned you had to borrow for the or rent for the extra day.
Yeah.
How much? It would seem like we ought to.
So this is actually what we're doing, So I have this lab that the Dean of Natural Sciences gave me some money to complete, to build, and Sandy and Aaron know about this. And it's really available for anyone on campus who wants to use it. And so it's got embedded cameras, and it's got a sort of a smart board for collecting drawing data. And then we've been writing lots of grant proposals to try to get about $40,000 for the iDrive. And I think I've maybe got a deal going on. So.
Just take public time for. If you get a bunch of faculty together, I can take it. Great.
Okay. All right. We have a bunch of faculty together because there's actually people from 7 different colleges who would use this space and this system. And I will buy you a cup of coffee if you can do that for me. And I would say anybody else who's on campus who needs this kind of a space, just talk to me. It's open for anybody to use with training.
So in terms of the effects of color perception, is there any study which actually show that colorblind people behave systematically differently from others?
That's a really good question. Sheldon, Nicole, my cognitive scientists in the lab. I have, so what, here, the deal is that most of the research the fundamental research that happens in cognitive sciences works on people who have a dysfunction. So there's lots of work on dyslexia, for instance, because it's a difference. And so then you can understand fundamental behaviors and cognitive processes by looking at how those people are different from the norm because of that difference. I don't actually know of anything that says that people who are colorblind see things differently, except for that classic color blindness where you actually can't see a difference. So there are people who are colorblind who see gray, and then there are people who are colorblind who say don't see a difference between greens and reds, or people who are colorblind who don't see shading in the same way. So when you go online and look up, disability appropriate web design, and those are things that are talked about. So there is work that talks about that. I don't know if view perception, say for people who, like the subject who couldn't see any color, that his behavior was going to be any different than this. So I would say the little bit that I know, I don't think so, but I can ask my cognitive science colleagues and I'm sure they would have a better answer. So, I don't know.
I just was going to ask, I don't know how much you analyzed it or your best guess, the differences between the two colors.
Mm-hmm.
The rainbow palette is something that we're used to, and you talked about that people wouldn't be jumping to the key as much because they assume they already know what it is. So how much it was difference of color versus newness of a scale?
So what was interesting was that when we did an hour-long interview with everyone. We have eye tracking for all of that, but we're not. It's just too much data. But the interview data, which is another rich data set, most of our subjects preferred the rainbow palette. And the reasoning for the preference was, I'm used to it. Right? Now, that may be true for temperature. And in fact, it may be a perfectly fine temperature palette. I would say, and I know I teach a global climate change class, and I know when I grab an image that uses the same palette that's portraying something other than climate, that the students, or other than temperature, the students in my college course do not view it as anything but temperature. So there's a whole cohort during that first 10 to 30 seconds of just looking at it, it's temperature. They don't even look at the key, they don't look at the scale. And so maybe the rainbow palette is perfect for temperature, but do we use it for salinity? That would be my question. I have to study it. I don't know if we have time.
Oh, yeah.
Oh, yeah. One of you. Yeah.
Yeah, very interesting work. I'm wondering if you saw any relationship between how much somebody liked it from an aesthetic point of view, and also like how useful it was for them. So there might be an instance where somebody liked the purple shaded map better just because it made them feel better, but they got more information out of the color map, even though it's a harsher kind of contrast.
So that's something, I don't know, Scott, if you want to speak to that, but that's something that we're analyzing, because we do have this information that's affective. We both have, what is the temperature difference between here and here? Where are the hottest zones, where are the coldest zones, those sorts of things. So we have that interpreting the data set that's in front of you information, plus which one do they like better, because we asked that question. But we haven't analyzed yet.
Which one they like better and which one they get more information out of. We would ask them, what do you think is the more effective one? And a lot of people chose the rainbow palette. And so we put little squares
This is cool.
on parts of the image where there was obviously much more detail on either the gray scale or the purple scale. And they kind of went, oh, I see, this really is. So they were thinking they were getting more information off the rainbow and liking it. And then when we show the other, they say, okay, for a lot of areas, does provide a better data set. But some people would then say, but I still like this one.
Let me just show you an example. So this is actually the Himalaya, which are the highest places on Earth. You don't even see it on the rainbow scale. It's just not there because it's that green. And again, when I look at it, I don't even see that this is something. It's a background. Whereas on the purple and the gray, it pops. And the same is somewhat true for the Andes. The Andes are actually this green strip here. You really see them on the purple and the gray. And I'm a tectonicist by training. I did high elevation plateau work early on, and so this pops for me. The only person who really viewed this area was an expert who does research in these kinds of places, so he knew what he was looking at, whereas the novices just didn't look there.
A really fascinating work. Very impressive. I have a question related to this kind of a grayscale preference for scientists. I guess that one of the reasons for that is that we basically, when we publish, we select grayscale because it's cheaper. So I was wondering whether you thought about using different projections with grayscale, and then that would affect how we perceive, and maybe kind of.
Yeah, so you mean like okay, now the names of the different projections are not coming to mind, but a
more
repeater.
Yeah.
Okay, so a cylindrical, those sorts of projections. Yeah. So actually, we have another set of these maps that Robert made in different projections. That's something we're really interested in. So one thing that's interesting is this is an equal angle projection, yeah, because it stretches out the land on the poles. You can do the same thing, which is equal area, where each cell has the same amount of, maybe I'm getting it backwards, but anyway, you can project these in different ways. You can project, which we've seen sort of the square projection. You can actually do a triangular projection, a pyramid. You can do a sort of 3D, you can do it so it looks like a globe, as the images that I showed you early. And again, that's a question. So one of the things that, I'm sure it didn't get funded, but we wrote a big proposal, and one of the things we wanted to do was look at everything from simple black and white sketching, those sorts of cartoon-like drawings, all the way through these sorts of projections, through animations that you control or that other people control, all the way through those magic planet systems, which are those 3D spheres that you project this information on. Do any one or group of those in concert provide more salience for the person who's viewing that data? So thought about it, have not done it. If you should have a question to let us know, especially if he gets us on track.
We all heard it.
I know. He's telling me. Can I get her in?
Yeah, definitely.
But I don't want to go too long, so.
I was just wondering, you did mention in the beginning that you interviewed sort of novices, experts, and then intermediates too.
Yeah.
I was just wondering if you could talk a little bit more about who those intermediates were and kind of where they fell on that.
This is how we did the study. We had a eye tracker. It was a renting of opportunity. So we put out a call to geography and geology departments, and to all the faculty, the grad students, and the students in their entry-level and non-major courses. Okay. So we used the Geoscience Experience Questionnaire to categorize them roughly, and they fell into these nice categories. We had some people who actually had never taken any sort of course. A friend told them about it, and they had no, at least past high school, no geology, no geography, nothing like that. People who are in an entry-level non-major geology or geography course, then those were the novices. Maybe people who had finished such a course. The intermediates were undergraduate majors and graduate students in geology and geography. We had to, oh, wait a minute, geographers may not have geology courses, but they do have the geography, which is often very similar, and maybe even has more training on how to view these. And the experts, there were 6 people that we coded as experts who were either faculty or advanced experiences in those domains. So gender and gender was distributed. There was a tiny bit of ethnic diversity, and the age actually ranged from 20 or 19 all the way through 60. And a cognitive scientist would say, "Whoa, you can't do that!" But you know, this is learning sciences research. So.
This is really cool. My inner science nerd is very excited.
Sit in the corner and just play.
But I mean, it sort of leads me back to the first presentation even. I think it would be really interesting to look at, you know, I mean, obviously a larger population or sample, but look at people who, you know, view climate science as something that is real or not. And see if they perceive these images differently, if they process them differently, because I mean, then you can tailor messages for different media sources, different outlets,
That's
different
exactly
types
right.
of things that people listen to and look at. And I don't really have a question, but I think it's really interesting to be able to go forward and look at differences between populations that view these differently.
That's exactly right. And so the Knight Center for Environmental Journalism on campus, David Paulson, who's the associate director, we've been trying to collaborate with him because he is the one who, Scott and I had a meeting with him and a communicator, And he was one who said, we said, scientists don't really know how to portray these messages, not always, to other people. Some people have a sense of this. And he was one who told us, well, we just go to the NASA, the USGS, the NOAA websites and grab these data. We assume the scientists are portraying it in the best way possible. And I think best for cognition and perception differs depending on who you are. And I'm really fascinated with these ideas of political affiliations. How does that impact your view? Because there are things, and are you urban or rural? We have some scholars in our lab who are looking at place and the role of place in understanding. So.
Just to reinforce that, there's a new paper by Jim Hansen and his group.
I'm talking about
Oh. I can email it to you. Where you know there's this flap about what about the last couple of years has been cold, and you know the point is, well, climate is multi-year average. It's not this year's weather, and the aughts are the warmest. And this paper gets in sea level temperature with several different approaches to it, and the aughts are the warmest decade in recorded history.
Right.
But there are these very simple graphs that everybody in the community are used to seeing. And the sense, I mean, I'm involved in discussions about how do we communicate this to the general public at sort of high levels in the academy. And there's a sense that these graphs will do the job. This is, wow, this is really definitive.
I would say absolutely not.
Yeah, and there's no sense of the kind of work you're doing amongst the people trying to do science communication.
So this is just one, I just this one simple thing. This is a graph of sea level temperature. We've all seen this in some form. And this is absolutely output from a MATLAB or Mathematica program. And I can look at it and I'm like, I know what this is. I've done this output before. And it's in written down the way a scientist would write it. And I just want you to notice something that pops out to me without even eye tracking data, which is there are these funny spaces here. Right? And I don't know what those are. Okay, now I can figure out it's a comma, it's 400,000. People in my global change class, they really have no idea what that means. This says years before present. Present equals 1950. When I look on the scale, I don't see the word present anywhere. I see a 0, right? Okay, as a scientist, I know what that means. You guys can figure that out. It takes too many cognitive steps to get there. If this is something people are seeing in an article. Obviously, people are smart enough to figure that out. Who's going to take the time? Right? I don't have the time, let alone someone who's just reading a news article. So that pops out at me, let alone all the eye tracking I want to do, an interview. I think one more, but then we should go to the next.
I don't know if you got a sense of this from the interviews, but I mean, some of the maps are, you know, the color maps, red obviously connotates for novices, probably connotates more fear, worry, what have you. But I guess A, is that true? And then B, I mean, there's some maps that I've seen that are like, you know, especially the latter century maps are like all red, like the whole, you know, especially on the A1 scenarios. Do you get to a point with, you know, connotating caution or connotating fear that you basically lose people because they see no hope? So there's a need for connotating some fear in the red, but then you can connotate so much fear that people just say, I can't do anything.
So this is what's interesting, and Scott, pop in if you remember something differently, but I did a cursory, I've done a sort of initial cursory look at some of these interviews, and the red actually connotates hot. The blue connotates cold. I imagine for an all red map, it might have a meaning of fear. On these, I don't think there was no discourse about anything but hots and colds. And it was automatic. It's a temperature map, it's hots and colds. And it wasn't just the novices, it was everyone who said, well, the blue's obviously hot, or cold, and the red's obviously hot. And then, of course, we have, ooh, let's switch it. But, I mean, we know what would happen, right? People would misunderstand. So it doesn't actually mean fear in this context. It's a different context. If it was disease, right, or children dying, or hunger, it might, but it's temperature.